Welcome to lesson 56 as we're talking about plotting functions. Functions is a term that's going to become more and more prevalent in your math career, and it's not something that's really new. Initially, we looked at it in different kinds of patterns that we have understood. We've explored patterns in sequences, we've explored patterns in other types of formulas, but now we want to start to really work with, well, how do we write the patterns ourselves in a way that we could solve for any variable or any input or output that is given to us. Let me demonstrate what we're talking about as we look at plotting functions. It says Jamal is ordering chairs for the furniture store. The function table shows the number of chairs he ordered for each table. Right? So what we're seeing here is, as we look over here at our table, we see that he ordered one table. He also got 4 chairs to go around that table. If he orders 2 tables, he's going to need 8 chairs. If he has 3, 12, 4, 16, and we could continue on with this table. Part A says, write a rule in words that shows the number of chairs Jamal orders for each table. Excuse me. What are we looking at here? What we're looking at here is the fact that we need to kind of understand the pattern. And we usually start with the input to help us understand it, and the output is the result. And so if I buy one table, how am I going to figure out the number of chairs? What's the relationship of 1 to 4? Now, some might say, well, you're going to add 4 chairs on. And to a degree, that's true, right? But if I said x plus 4 as my pattern, would that work for this one? So I would say, okay, 2 stands for x, so plus 4 equals 6. All right, so it's not really adding 4. There is that idea there, similar idea, but it's not really adding 4. Instead, we would say for every table x, I need to be able to have 4 chairs to go with it. So 4 times x. So in words, I would write that as for every one, let's write it in word, 1 table multiply by 4, words, to get the number of chairs. Sounds like a lot to write, but by putting it down in words, we get an understanding of what the rule really is. Now that we see that, identify it, how do we use that? Complete the table. So if I have 5, right, for 1 table, multiply by 4. So for 5 tables, still multiply by 4, and in the end, I get an answer of 20. And then at the end, we can write an equation. When we write an equation, we put it in terms of input of x and an output of y. So output means what is it going to equal? And usually we start with the output. Y, that's just math being math, right? But we put y down first as our output, and it's going to equal, right, y equals x. And how does y become this? Right, we already talked about this. 4 times x gives us y. And so the rule of this table here is y equals 4 times x. Let's keep working with this idea, and as always, if you have a question at this point, jot it down and be ready to ask it sometime in class. From here, we can talk about the fact that functions can be put into a graph and put on the coordinate plane, and it really helps us interpret the data that is being displayed in the tables. So let's take a quick review. When it comes to the coordinate plane, we have 4 quadrants. Quadrant 1 has an x and a y, and both of them are positive. Right, so we got positive 1, positive 2, positive 3, positive 1, positive 2, positive 3, positive 4, and so on. And here in quadrant 2, we're doing the opposite, right? Now we got negative 1, negative 2, negative 3. And then if I were to put a point here, right, my y would still be in the positive range. Quadrant number 3, of course, then, is going to be the opposite of quadrant 1. It's going to have two negatives. I'm going to the left, so I've got negative x's. If I go down, I got negative y's. And then, of course, quadrant 4 is talking about this, right? X quadrant, x, I always do my x first. So I go over x and then down my y. If it's a negative, it means go down. And so we have these principles. As we look at these principles, it helps us to understand what we want to do when it comes to graphing different kinds of functions. So that's just a simple review. And now we want to move into reading a chart that uses these principles. So if I gave you the rule of y equals 2x or 2 times x, we can understand what is going on here. And so this is our function, y equals 2x. From here, a table can be built. If I put 0 in for x, 0 times 2 equals 0, so 0, 0. And so forth, you can see as the pattern continues. From here, what we want to do is work with graphing this, putting it on the coordinate plane. So 0, 0, of course, is what we call our origin. So it goes right there. Then I'm going to go with my next point, x first, x over 1, so 1 over, and then 2 up. So there's my second point. All right, from the next one, I'm going 2 over, 4 up. Continuing on, 3 over, 6 up, and 4 over, 8 up. And as we look at this, what we're starting to see, hopefully what you're starting to see, is that there's a pattern forming. And what we can do with this pattern then is we can join them together in a line just like this. And if we were to continue building this, we would see that the line is going to continue to intersect. So we definitely need those arrows there as we're working with this. The other thing that we can see is while we're not really working with this, technically our line goes the other direction too. It continues in the negative fashion. Right, so if it was negative 1, it'd be just like this. And while my lines are off a little bit, I didn't technically start in the exact same spot. Let me try and adjust them to make it look pretty. There we go. We developed this really, really nice line that we can now use to interpret our data and resemble what's going on. However, like all things, sometimes we're not given the table. Sometimes we're given the line. So here's your sample. Find 3 points on the line that you're seeing here, and then tell me what the rule is. What is the function for this line? Write it as an equation or write it in words. The equation is definitely preferable. That's it for lesson 56.